Hi everybody, welcome to this new AWS webinar. My name is Julian and I'm part of the technical evangelism team focusing on AI and machine learning. And today I would like to talk about building machine learning workflows with Amazon SageMaker, our managed machine learning service, and AWS Step Functions. So here's the agenda. Obviously we'll start with a quick introduction of Amazon SageMaker and Step Functions, just to give you a quick idea of what those services are about. And then we'll talk about how an AWS customer called Cox Automotive is combining those two services to help with their machine learning deployment and how they can improve collaborations between teams. It's a very clever architecture, and we'll cover it in great detail. And then we'll close the session covering some additional features where SageMaker and Step Functions can collaborate to help you build faster and easier machine learning workflows. So let's get started. First, a quick intro to Amazon SageMaker and Step Functions. So Amazon SageMaker has been released at reInvent 2017, so it's about a year and a half now, and it's a service to help you go from machine learning experimentation all the way to machine learning deployment using the same SDK, making it as easy to go quickly from experimentation to building models, to training models, to deploying models. And this all relies on a Python SDK that's very high level, very easy to use, and everything happens on managed infrastructure. From experimentation to training to deployment, you never manage a single server. So that's very convenient. You can focus on the machine learning task using either built-in algorithms or built-in environments for popular frameworks like TensorFlow, Apache MXNet, PyTorch, scikit-learn, and more. So it's really an accelerator for your machine learning workflows. And this is used by all kinds of customers, from startups to enterprise customers. We see strong adoption across the spectrum, all company sizes, all verticals. So, it's really a very flexible service that seems to fit all kinds of workloads. If we look at the typical machine learning cycle, and if you're not familiar with machine learning, don't worry, we'll cover those steps. We start with a business problem, a question that you want to answer. For example, I want to predict which customers are likely to stop using my service in the next 30 days, or I would like to know if this e-commerce transaction is fraudulent or not, etc. So you start with a business problem that hopefully data can answer. So you frame the problem into a machine learning problem, trying to figure out what kind of data will help you answer that question. And then you move into the early stages of your machine learning process, which is really about data. So collecting the required data, integrating it in a central place, cleaning it, so filling missing values, transforming it in a format that's appropriate for machine learning, etc. So lots of data engineering. Fortunately, on AWS, you have a nice collection of services, and let's call them big data services, from storage in Amazon S3 to ETL with Glue, to actual analytics using maybe EMR if you like, Hadoop or Spark, Athena if you want serverless operations, or Redshift if your data is hosted in a data warehouse, and obviously SageMaker to get some of the cleaning work done using maybe notebooks. So that early phase, I would say, is pretty well covered by those different services. And once you have a data set that's ready for machine learning per se, then SageMaker, using notebook instances, for example, lets you visualize and analyze the data, try to get a sense of what that data looks like, and then you can move on to the actual machine learning task of feature engineering, building high-level features from the raw data set, to build successful models. And then obviously you go into training model and tuning parameters for the models, in order to increase accuracy, and then you measure the quality, the accuracy of the model. It's called evaluation, using a different data set, so data set that hasn't been involved in training. And then you get to the point where you have to decide if the model is accurate enough to be deployed. Does it successfully answer the question or not? And if it does, then you move into deployment. And again, SageMaker lets you deploy your models to fully managed infrastructure, which could be web servers backing an HTTPS endpoint serving predictions, or it could be batch transform, where you literally batch predict a data set and then get results in Amazon S3. Okay, and then of course you need to monitor your model, you need to monitor performance, latency, etc., etc. So SageMaker lets you cover the training part, the deployment part, and the experimentation part, all of that using managed instances. So no need to fire up EC2 instances and install them. You work with instances that are just covered by SageMaker. But okay, we talked about the boxes, but we didn't talk about the arrows, and some of those arrows are important. So we'll consider later on the deployment arrows, and well, what happens then? Okay, so sure, this could be a manual process, or this could be an automatic process using the SDK, but each of those arrows is a transition between important stages, and maybe if you want to automate everything, if you want to build reliability and predictability into your process, maybe you need some kind of tool to orchestrate all of that. And this is pretty much what AWS Step Functions are. So let's take a simple example. Let's say I want to build a photo sharing app where I can upload photos. And once I upload a photo in Amazon S3, I want to extract labels. Okay, so I want to use Amazon recognition maybe to figure out what's in the picture. Okay, extract text labels. And maybe I want to generate a thumbnail. So a smaller version of my image that will get displayed in my photo sharing app. Okay, so well, quite a few steps are happening here. So if we look at step functions, we would define a state machine, and okay, that would start by uploading an image. So it would be triggered, it would be started by that event, uploading an image to S3. Then we would run a first task, which would be extract image metadata. And that task would first check that the image has the right type. That is a supported format. If it's not, then we're failing. And maybe notifying failure to another application, or send an email. Why not? If the image has the right type, then we move on to another function who will actually call recognition and generate the thumbnail. And notice we can do those things in parallel. So when you define a workflow with step functions, you can have tasks, so you actually compute stuff. You can have choices, you can have sequential execution, you can have parallel execution, and it's very easy to define those machines, those state machines. You can define them visually in the AWS console, or obviously you can use APIs and define them programmatically. Okay, and this is pretty much what step functions are. A combination of steps and transitions and conditions and tests, etc., etc. So it's a very natural way to define workflows. So here's a basic example, still using the image example from the previous slide. So this is a JSON, right? And this is actually what we call the Amazon states language. So it's the step functions language, definition language, if you will. So we start with extract image metadata, okay? And that's the first step in that workflow, okay? And we can see that this state actually is a task, so we're going to run compute here, and this compute operation will be performed by a Lambda function. Okay, so we have a Lambda function that will get automatically invoked when that state machine starts. Okay, And we can see that if this function has executed, then the next step is to run another function, probably called image type check, and that's how you define the transitions from one step to the next. And we can process errors. So if we have exceptions, if something doesn't go well, we can catch the error, and we could, in this case, send or iterate to the next step. In this case, not supported image type, and we can retry. So we could have all kinds of things could go a little wrong. Maybe we can have timeouts. Maybe you could have any kind of issue. So we can define delays, maximum attempts to retry, the back-off rate, how long to wait between attempts, etc., etc. Okay, so again, pretty robust system where you can also manage errors when they happen. So when it comes to performing tasks, to actually getting work done, there are two options in step functions. So the first one is the one on the left. It's called the activity, where once a workflow is running, you can actually have external compute resources that poll the state machine, saying, is there any work for me, right? So it's a pull mode, if you'd like. So let's say a container running on Amazon ECS, or an application running on EC2, or even a Lambda function, any kind of compute service could use the AWS SDK to poll that workflow and ask the state machine, is there any work for me? Yes or no? And if there is, then we get information and we process it. The second way is it's a bit of a push mode or synchronous request, where compute steps, as we've seen in the previous example, will invoke a Lambda function synchronously and ask it to get the job done. Okay, and the Lambda function returns a result, and the state machine continues. Okay, so we have those two options: either pull work from the state machine using any kind of compute service, or run synchronous Lambda functions and get the job done. So let's look at a concrete example. Let's look at what Cox Automotive did. So Cox Automotive focuses on buying, selling used cars. So they're trying to make this the used car market more efficient for buyers and sellers. Okay, so check them out. They have lots of AWS use cases, and here we're going to talk about what they've built with Step Functions and SageMaker. So here, the specific problem they're trying to solve is that highlighted part. So how do you actually decide to deploy a model? So assuming the model has been trained and evaluated and you're happy with it or not, how do you make that call, and how do you deploy, yes or no, the model? So the way they do it is, and the way lots of AWS customers do this actually, is they want to have a manual inspection. Okay, they need a data scientist, they need an expert to look at how the model was evaluated, what the results are, what the diagnostics are, and they want that expert to make the call and decide if the model needs to be deployed or not. Okay. But then the question is, how do we minimize the time that the data scientist or the decision science team, as they call them, how do we make sure they don't spend time on ops? Okay, because that team should only be working on models and evaluating models, and if they're happy with the model, they should say, yes, we're happy with the model, and then it should go into the deployment pipeline, and the engineering team should just make sure that the pipeline runs, and data scientists should be able to go back to doing actual machine learning work and not get bogged down in engineering details, which are important, but that's for the engineering team to handle. Okay, so it's really having a human in the loop, but making sure that expert human doesn't spend more time than is absolutely necessary. So their setup looks like this. So they have a VPC, a virtual private cloud, on the left where they train and evaluate models. And on the right, they have their production VPC where models will enter the deployment pipeline and end up in production. So first, models are trained on SageMaker. They are written to Amazon S3. Okay, so that's what SageMaker does. Once a model has been trained, the training infrastructure is shut down automatically, so you stop paying, and the model is written to S3. Okay, and that triggers a Lambda function. Okay, S3 is one of the event sources for Lambda, so the fact that this model is written triggers a Lambda function, and that Lambda function fires up a step function workflow. Okay, so every time a new model is trained and dropped in that S3 bucket, a workflow is automatically triggered. Okay. In parallel, a Lambda function is scheduled every 5 minutes. Okay, so in CloudWatch events, you can schedule Lambda functions. So again, CloudWatch events is an event source for Lambda, and every 5 minutes, a Lambda function will wake up and ask step functions, is there any work for me, right? Is there something I should be doing now, okay? And if so, step functions will pass the model information to the Lambda function, and the Lambda function will read the model from S3 with the evaluation information, etc., etc. Okay, so that's the early part of the process. Train a model, drop it in S3, trigger a new workflow, and then every 5 minutes, a Lambda function wakes up and queries the workflow and says, hey, do you have a model for me? Is there something I should do? Okay. So it's going to pick up the model and it's going to send an email with, as you will see, diagnostic information on the model and basically a link to accept the model or a link to reject the model. And this email is a simple email. It's built automatically by the Lambda function. It's pushed to Amazon SES, which is our email service, and this is delivered to the data science team. Okay, so now the data science team receives an email with solid information on the model. This minimizes human error because the Lambda has picked the right model, the right files, so that email is reliable. Data scientists don't have to go in S3 and figure out which model they should be looking at. Okay, they have everything they need in the email. And so in that email, like I said, they have diagnostics and they have a yes or no link, pretty much, approve or reject. Okay, so they will look at the model, do what data scientists do, and then they click on the appropriate link. So let's say they approve the model. This invokes a REST API hosted in the API gateway, which is our managed service to build REST APIs. That API is wired into another Lambda function, okay, which will update the workflow saying yes, the model was approved or rejected, but okay, let's say it was approved. So it updates the state of the workflow and the workflow advances. And this fires up a final Lambda function that will grab the model from S3 and push it to the production account in a bucket owned by the production account, and then that sends a notification to the delivery pipeline, and eventually the model finds its way in production. Okay, so it's a very clever example because they automate a lot of steps, right? And it's not a lot of code. They rely on a lot of managed services to do this, and they only have a human in the loop where it matters. Okay, where the human expertise is really needed, and in that case, it means looking at the model and clicking on the link, and then moving on to other tasks. So not worrying about the rest of the process because it is automated, and they trust the pipeline to do the right thing. Okay, so not wasting data scientists' time to supervise engineering tasks. So this is what the state machine looks like. So it starts and ends, okay, and we'll find the steps that we just talked about. So there's a first Lambda function called get new model, okay, so the one that is scheduled every 5 minutes and queries the workflow, okay. We have another Lambda function called get manual review, so the one that builds the email and sends the email to the data scientist, okay, and then we have another step to figure out whether the model was approved or rejected, so it's a choice, okay, and that will be based obviously on which link the data scientist clicked on. If the model is rejected, then okay, nothing happens anymore. If the model is approved, then the final Lambda function runs and deploys or copies the model to the production account. Okay, so we see the state. This is pretty straightforward JSON. We see the Lambda functions. And I guess the only thing worth mentioning here is the timeout on the get manual review Lambda. I think this is in seconds, and it's a week, I believe. So they give a week to the data science team to say yes or no, we like the model. Okay, so very easy stuff, right? No, nothing complicated. So let's look at the different steps. So first, we need to grab, so that's the first Lambda function, the one that wakes up every 5 minutes, queries step functions, and you can see this in the first few lines of code. It queries the step function using the Boto3 SDK. This is Python code, of course, so we use the Python SDK. So we get information on the workflow. We have a task token which is part of the response. Okay, so this is information passed by the step function to the Lambda function, and then we build an email. Okay, with sending that to the data science team, and the email has the token itself, which uniquely describes the model in S3, and we have the diagnostic files that data scientists need to look at, and that's about it, right? And you can see sending the email is as easy as, again, using Boto3 to connect to SES, Simple Email Service, and just building a simple email with two URLs backed by the same API, one for approval, one for rejection. Okay, so that's pretty much what we've described so far. So this is what the email looks like. So it's a simple email. They haven't spent much time on making this look really nice, because the important thing is obviously the diagnostics, and then just click on approve or reject. Okay, and so that's what the email looks like, and it gets sent to the data science team. So obviously they download the file, inspect it, make sure they're happy with the model, and then they click on either the approve link or the reject link. Okay, and again, this is the same API with two resources. Okay, approve or reject, and this is hosted in the API gateway. Okay, so in the API gateway, we see those two possible options. So there are plenty of ways to configure the API gateway. You can do this in the console. You can do this with CloudFormation, etc., etc. It looks like they use Terraform here, and obviously you pass the task token to that API. Okay, and that's about it. So setting up APIs with the API gateway is pretty simple. And so, like I said, this API is wired into a Lambda function. So the Lambda function will be invoked automatically when the links are clicked, or the link is clicked, I should say. Only one link is clicked at a time. And the Lambda function gets the parameters for the API call. So they look at, in this case, the path. So does the URL path contain reject, or does it contain approve? Okay, and then according to that, we build a message, and we build simple JSON argument file with the task token and an output that says failure or success. Okay, and this is then passed back to the step function. Okay, so this updates the state of the workflow with the token and more importantly the output. Okay. So an interesting feature in step functions is that as you see, we have a sequence of Lambda functions being invoked, and each of those functions has some kind of state, and you can actually keep trace of all those states. Okay, each Lambda function can actually add some state output to a JSON object that is passed along, the different steps. Okay, so this way, one downstream Lambda function can see what was the output of an upstream Lambda function, and it can use this as parameters, as we will see in a couple of slides. And you can also maintain a log of all the states that the Lambda functions had, right? So you keep a log, literally, of the execution for that step function. Okay, so for example here, the get manual review function can see will output some state saying, well, this specific model was approved. Okay, and the get new model function that took place before outputs the diagnostic file. Okay, so basically the get manual review function would be able to access that information from the get new model execution and say, okay, which file are we talking about? Okay, let's just look at the output from my previous my upstream Lambda function, and I can pass information from one Lambda to the next. Okay, and this is super useful. You don't have to come up with exotic ways to store state in step functions. You just append output to that shared JSON document, execution after execution. Okay, and here's another example. So now the approve or reject new model function will have to decide if, or the data scientist will have to decide if the model is approved or rejected. Okay, so based on that, we will output additional information in the form of a variable called task result dot decision. Okay, and this is going to be equal to either approved or rejected, depending on what the data scientist decided. Okay, so that's how we could keep on building on that story. But there are more features I want to talk about. So in a nutshell, this is how Cox Automotive is getting the best of both worlds, so to speak. They get automation for the steps that are safe to automate, and they get a human in the loop for the one step that they really want to make bulletproof, and they need a human eye to look at this model and decide if the model is fine or not. And you can integrate those automated steps and those manual steps in the same workflow. Okay, and it's very little code. It's very little code because each individual function makes tiny decisions. So these are easy to write, easy to test, easy to debug, and you just focus on the task at hand. And again, you don't have to come up with exotic ways to pass information, using backends or whatnot, or inventing crazy plumbing to get the workflows going. Right? Step functions will make sure the transitions are happening the way they should be, and you just focus on the tiny bits of code that need to run at each specific step. So let's go back to our story of combining SageMaker and step functions and look at some additional features that will make your life much easier. So if you work with SageMaker, and I would say in general, if you work with Jupyter notebooks, you probably write code like that, right? So first you retrieve data, either from the internet if it's a public data set, or from S3 maybe. If you're using internal data, maybe you're pulling data from another backend. So you need to get some data to work on. And then you set up your training job and you select an algorithm and so on, and you train a model, okay? And then once you've trained a model, you want to predict with the model, see how it behaves, et cetera, et cetera. Okay, so it is a workflow. So when we're experimenting in Notebook, we value flexibility and agility, and of course we're going to run those steps manually, and we're going to tweak them for hours and hours. So we don't care so much about automating, but at some point, this workflow makes sense. The model is trained correctly. It has the right level of accuracy, and now you want to deploy it. Okay, and well, it would be, I guess, a bad idea to just use the Notebook to do that, because the Notebook is really not a production tool. It's really an experimentation tool. So of course, we could take the same code, we could split it in Lambda functions. That's very easy to do, and we could build a solid workflow in step functions, downloading the data, training, waiting for training to complete, and then if training completed successfully, then we go on and deploy the model or predict with the model, etc., etc. Okay, and that's perfectly reasonable, except that we have some asynchronous steps in here, right? We have to wait for training to complete. We have to wait maybe for deployment to complete. We have to wait for prediction to complete, okay? And well, this can take a while if you have large training jobs. So polling for the end of that asynchronous step, yes, it's possible, but it's not super convenient. So fortunately, you can actually very easily manage asynchronous jobs in step functions. You don't have to write the polling code. Okay, and this would apply to SageMaker training, SageMaker deployment, SageMaker prediction, or if you want to use Glue, which is our managed ETL service, it would work the same, right? ETL can take a while to run, so you don't want to be polling every 10 minutes or every 15 minutes to check for completion. So there's an easy way to actually run those jobs. Let me show you how. So our workflow now becomes this, okay? So we just pretend they are synchronous jobs. Okay, we ignore the fact, because step function is going to work some magic in here. We just ignore the fact that these are synchronous jobs, and we build a simple workflow that really focuses on the tasks and not how they're implemented. Not, okay, is this synchronous? Is this asynchronous? No, we want to download, train. If training failed, okay, then that's the end. If training succeeded, then create the model and predict with it, etc., etc. Okay, so obviously the workflow on the right is much easier to understand than the workflow on the left. And this is how you would do this. Instead of writing a Lambda function that would poll for completion of a Glue job, in this case, you just use the specific resource type, okay, which is, in this case is called start job run, Glue start job run sync, okay, and so this will fire up a Glue job, and it will not, the transition will not happen until the job is completed. Okay, so we make asynchronous tasks look like they're synchronous. So you don't write extra code, just say, hey, run Glue, and obviously when Glue has done its thing, if the task succeeded, then please let's continue. If the task failed, then log an error and then maybe stop the workflow. Okay. And we can do the same thing for SageMaker, okay, using SageMaker create trained job sync or SageMaker create transform job sync. Exact same story. We just make those asynchronous operations look like synchronous operations, okay? So you don't have to write extra plumbing, extra code to deal with completion and success and failure, etc. Just fire them up, and step functions will keep running the workflow once the job has completed. Okay, this is really super cool. This is a huge simplification. So you simply define your workflows in JSON, just like we've seen Cox Automotive doing. So start with downloading your data set. So maybe here you run a tiny Lambda function that downloads data from the internet, from S3, and drops the training data in S3, because that's where SageMaker needs it. And then you simply define a training step using that fake synchronous operation, so to speak, right? The create training job.sync, which will fire up a training job and we'll see the same parameters as we see in SageMaker. So selecting an algorithm, here we use the built-in algorithm for image classification, and then we would pass additional training parameters, just like the ones you are using if you use the Python SDK in SageMaker. Okay, and this could be lasting for 5 minutes, or this could be lasting for a week. It doesn't matter. Step functions will just wait for the job to be complete before it transitions to the next state. So the combination of those services is really great, because SageMaker is really nice when you're experimenting in your notebook. You have the flexibility to use the built-in algos or the built-in environments for the deep learning frameworks. You can train in local mode on your notebook instance, or you can fire up training at scale on managed instances, etc., etc. So you have all the flexibility to experiment and train manually, and then when you want to automate, okay, then it's actually easy to slice your notebook into steps that fit into a step function. Okay, just like we saw. So you will have a tiny Lambda function to download the code, and then you can use those synchronous operations to train and deploy and transform. And these are very, very easy. No code. It's really just configuration. Okay, what does the training job look like? What does the deployment look like? Okay, and you have the guarantee that step functions just will enforce the workflow. If it takes 5 minutes or 2 hours or 2 days, it doesn't matter. You don't have to worry about those asynchronous operations. So obviously, once again, we want you to focus on machine learning. We're trying to make machine learning easy for everybody. So we try to make machine learning easy for developers who have no machine learning expertise. And I guess here we're trying to make machine learning deployment and machine learning automation easy, maybe for data scientists who don't have a lot of engineering experience. Okay, so we're obsessed with making everything simpler for everyone, and the combination of those two services, I think, is really, really interesting. So if you want to get started, I would recommend checking the free tier, which is that first URL. So the free tier is basically a way for you to use a lot of AWS services completely for free within the first 12 months of the creation of your account. Okay, so please check this web page. You will find the usage limits for each of the services. So SageMaker is in there, step functions are in there, Lambda functions are in there. So if you want to build a quick POC or just get a sense of what those services are about, you can do it for free if you check the information on that page. So I think that's important. ml.aws is the high-level page for everything machine learning at AWS. So that's a good name, a good URL name. You'll find information on all services and documentation and pricing and customer references and so on. So if you're new to machine learning on AWS, this is the place to go. If you want to know specifically what SageMaker is all about, then this is the next URL. Again, features, documentation, pricing. SageMaker has a ton of features, which I'm sure will be covered in other webinars, from a hyperparameter optimization to reinforcement learning. So it's a very exciting service, and you will learn all about it at that page again with customer use cases. And the same goes for step functions if you're curious about this service and how easily you can build workflows with it. Again, go to that last URL and you will learn a lot. Okay. So lots of stuff to do, but please check the free tier. I know this is important, and if you want to, if you want to experiment at no cost, this is the place to go. And actually, a lot of services are in there, so not just SageMaker and Step Functions. I want to thank you very much. I hope this was informative. I hope you learned quite a few things about this combination of machine learning and step functions. That's a pretty new topic. I think it's a very exciting topic because now we can automate machine learning as well, make it fast and automatic when we want to, and still have a human in the loop when we need to. So very, very interesting. If you want to stay in touch, this is my Twitter account, JUL Simon. I would love to hear your feedback on the services. If you have technical questions later on, you can ping me. If you're building cool stuff, if you posted a nice blog post on your personal blog or on your company blog, please share it with me. I'm more than happy to retweet and share it with the community. And last but not least, this is my blog on Medium, where you will find a lot of machine learning and deep learning posts and quite a lot of SageMaker content as well. So if you want to learn more about SageMaker, see more examples, you might like those posts as well. I want to thank you very much. Please stay with us. We will be answering your questions. So send all your questions. We'll try to go through all of them. And again, one last time, I would like to thank you for being with us today. And please check out all our other webinars. There's plenty more to learn. Thank you very much and have a great day.